FastMCP 2 implements protocol-native background task execution through its task equals true decorator parameter, enabling asynchronous operation with built-in progress reporting via the progress dependency injection system. This mechanism allows clients to initiate long-running operations, receive immediate task identifiers, and track execution status through standardized MCP protocol interactions. The upcoming code artifact demonstrates how to integrate progress reporting into a task-enabled function, showing the initialization of a FastMCP server instance, the decoration of an asynchronous function with task capabilities, and the utilization of the progress dependency to set total steps, update status messages, and increment progress during file processing operations. From FastMCP, import FastMCP. From FastMCP dependencies, import progress. MCP equals FastMCP my server. At MCP, tooltask equals true. Async def process files fails. List SDR progress. Progress equals progress SDR. Await progress. Set total and fails. For file and files. Await progress. Set message of processing file. Hash do work. Await progress increment. Return F processed lenfils files. This code demonstrates how to integrate progress reporting into FastMCP task-enabled functions using the progress dependency. The pattern shows a utility function that processes a list of files while providing real-time progress updates to clients through the MCP protocol. The function is decorated with @MCP, tooltask equals true, which enables background execution while maintaining the same interface for both synchronous and asynchronous calls. The progress reporting mechanism uses 3 key methods: set total to establish the total work units, increment to track completion, and set message to provide contextual updates. This approach follows the dependency injection pattern, where progress is injected as a parameter with a default value, allowing FastMCP to provide the appropriate progress reporter instance automatically. The implementation maintains clean separation of concerns, with progress reporting logic integrated naturally into the business logic without tight coupling. This pattern is particularly valuable for long-running operations where client feedback is important. The trade-off is minimal additional code complexity for significant UX improvement. The same progress reporting works seamlessly whether the function executes immediately or as a background task, demonstrating FastMCP's protocol-native task handling. The in-memory backend shown here is suitable for development, though production systems would typically use Redis for persistence and scalability. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. This import alone doesn't create any instances or configure behavior. It simply makes the FastMCP class available for use in the current namespace. From FastMCP dependencies, import progress. Imports the progress class from the FastMCP dependencies module, which provides functionality for reporting task progress in FastMCP applications. MCP equals FastMCP my server. Creates an instance of FastMCP with the server identifier myServer. The string parameter serves as a label for the server that will be visible in MCP protocol handshakes, allowing clients to identify this specific server instance during communication. At MCP, tooltask equals true. Async def process files fails. List SDR progress. Progress equals progress SDR. Defines an asynchronous function named process files that is registered as a FastMCP tool with task support. The function accepts a list of strings named files and an optional progress object with a default value of a new progress instance. The decorator at MCP, tool task equals true, indicates this function is exposed as a tool in the FastMCP framework and is configured to handle task operations, enabling progress reporting through the injected progress parameter. Await progress, set total in files. Sets the total progress count to the number of files in the files collection. The progress object is a FastMCP progress reporter that tracks task completion, and this line initializes its total value to len files, establishing the expected number of work units for the operation. For file in files, iterates through each item in the files collection, assigning the current item to the variable file in each iteration. This is the header of a standard for loop that will execute the indented block below it once for every element in files. Await progress, set message if processing file. Updates the progress message to indicate the current file being processed, using an asynchronous operation to set the message. The progress object's set message method is called with an f-string that includes the file name, providing real-time feedback about the ongoing task. Await progress increment. Asynchronously increments the progress counter by 1 unit, updating the task's progress state and notifying any monitoring clients through the FastMCP progress reporting mechanism. The await keyword indicates this is a non-blocking operation that yields control until the increment completes. Return f processed lenfiles files. Returns a formatted string indicating the number of files processed, where lenfiles calculates the count of items in the files collection. The result is a message like processed 5 files if files contains 5 elements. FastMCP2's task-native background execution with progress reporting comes together through 3 key elements. The @MCP tool task equals true decorator that enables a sync operation, the progress dependency injection that handles real-time updates, and the clean integration of progress tracking into business logic. The decorator transforms the function into a background-capable tool while maintaining the same interface, while the injected progress instance provides the protocol-native reporting mechanism. The pattern's elegance lies in how set total, increment, and set message create a natural progression of work tracking without tight coupling the progress logic flows alongside the file processing without obscuring it. This approach delivers significant UX improvements for long-running operations with minimal code overhead, working seamlessly whether executed synchronously or as a background task. The trade-off of slight additional complexity yields protocol-standardized progress reporting that clients can monitor through MCP interactions, making it particularly valuable for operations where real-time feedback matters.
The progress bar sprints to completion, while the files still dream of being processed.